Hey, example 1, binomial expansion or binomial theorem. Same thing. Binomial theorem, binomial expansion. Let me write that also here on this side. Let me write binomial theorem also. Means the same thing. So if we see either one, binomial theorem or binomial expansion, they mean the exact same thing. So don't be surprised or be scared or like, wait, you didn't teach us this stuff, Mr. Hall. Yes, I did. Same thing. So here, binomial expansion or theorem. Example 1, we're going to expand x plus y squared. Okay, so again, we've already talked about this, the expanding part. So let's go ahead and look at it again. And we talked about this part right here. This tells you which line of Pascal's triangle to look at. And so here we're looking at the second power. So that means, again, when it comes to our triangle, we're looking at where that line is, the second line. So let's go and pull that up really quickly. Pull it back down. Up. There you go. All right, so the second line. So we have this part right here. So that means on our paper, we're going to write down those parts. Put a 1, some space there. Put a 2, some more space, and then a 1. Because we need to put in the x and the y's in there also, so we can make sure we understand what's going on. Okay, so we have that. Let's go ahead and make this a little bigger. Now, we have our coefficients. This next part tells us what we're going to do after the coefficients. So we're looking at things first and second term. So here, when we take a look at first and second term, this is going to be considered the first term. And so that means the y will be considered the second term. Yay, first and second. So when we start expanding it now that we have the 1, 2, 1, now the first term, which is the x for this part, we're going to start with the highest exponent and go down to, and let's uncover that part, 0. So our highest exponent is this part right here. The highest exponent. Isn't that great handwriting right there? It's amazing. That looks wonderful. Let's see if it will change over. All right, so that's our highest exponent. Okay, so that means we're going to start off with 2, and then we're going to go down till we get to 0. So let's do that on our paper here. So we're going to put an x here, an x here, and an x here. So in other words, we put that first term behind each one of those coefficients, and we start with the highest exponent. And again, this is the exponent's highest exponent is 2. So we start with 2, and we go until we get down to 0. So we do 1 and 0. So again, with the highest for the first term, we start with the highest exponent and we go down to 0. And then we get our second term. And let's make that bigger also. So for our second one, the second term, we're going to start with 0 and go up to the highest exponent. So we again start with 0 this time and go up to the highest exponent. So again, our second term is y. So with this, let's pull off this side. We write y here for each one of these. And again, we start with 0, and we go up to the highest exponent, which is 2. So this goes 0, 1, 2. Okay, so not bad so far. We got this. We can do this. We got this. So again, we went from the highest exponent for the first term and went down to 0. For the second term, we went from 0 and went up to the highest exponent. This part I like. Anything to the 0 power, we just get rid of. We mark it out. We say, like, we don't need you. So, again, so everybody can see it. Anything to the 0 power, we get rid of it. Anything to 0 power. So that means we can get rid of the y here. That's to 0 power. We don't need you. And the x to 0 power, we don't need you either. So we can go ahead and get right. We don't need that anymore in our answer. Okay, so the last thing to do is go ahead and rewrite all these things down. And if you want to drop the ones, you can drop the ones here. This is the time you drop those ones. You don't need them unless you just want them. And like here, I can drop those ones also too if I wanted to. All right, and then the last thing is to make sure we add our addition signs. So we just add positive signs. So in other words, we add one here, we add one here, and that's it. And again, if you want to drop those ones off, you can do that too. So we can just say is actually this. Now some of you guys might be like, oh my gosh, that's too much work. Oh, that's too much. Oh, that's too much work. I can't do that. I don't want to do all that when I can just do FOIL and that'd be fine. But again, remember, this is not gonna be squared. It's not gonna be cubed. It's not gonna be to the 4th power. It's not gonna be to the 10th power. It's gonna be something that's like to the 12th power or the 24th power, and they say find specific pieces of it. That's what they're looking for this. So this is just giving you an idea of how it starts. But then as we go forward, we're gonna do more and more with bigger exponents. And so here, just to show you, that's the same answer I got. All right, so we're going to give you a practice on this using Pascal's triangle, and then we're throwing Pascal's triangle out the window and we're doing combinations here. All right, so then let's check you out in that practice.